And welcome back, AP Economics students. Time for more free response question review. This question is actually from the year 2019. And this, on the year 2019, they started producing two sets of questions, and this is actually from set 2. So this question, they're kind of predictable. It's going to be one of the market types, so let's see what they say here. So the question says, Gigantic is the name of this pharmaceutical corporation, has a patent on a prescription drug, making it the only manufacturer of that prescription drug. Translation, we're dealing with a monopoly. Gigantic is currently earning a positive economic profit. Okay, and then it says to draw a correctly labeled one. So I'm going to make a quick sketch over here, and then we'll make a really nice one as if we're in the test situation. So you want to be able to very quickly just say, oh, monopoly making a profit. I got it. I got my chopsticks. I got my demand price. I got my marginal revenue here. I'm making a profit. So go ahead and pick a point in the middle of the chopsticks, and that'll be your ATC minimum. Okay, put that right there. There's my ATC minimum, and my marginal cost curve has to go right through there. I go back to my tattoo, MR equals MC, that is right there. That's my profit maximization. All right, and so my price charged for this quantity would be there. The cost would be right here. So this would be how much money I'm making. This would be how much revenue is coming in, would be the entire box. Up top here is the profit, and down here would be what it's costing me to produce it. So doing pretty well here with a nice little profit box. So that's what they're looking for. And they're always going to ask for each one of these locations to be highlighted nicely with the quantity and price in a nice, neat, and concise manner. So what I'm going to do is I'm going to draw a real nice one here. And again, I recommend having a straight edge here for the exam. You should have enough time to make a pretty nice sketch here. So I'm actually going to use this ruler here and see if we can make something real nice here. So there is our price axis. Here is our quantity axis, and I'm actually going to even make the chopsticks here, make these real nice. So there's my demand, and here is my marginal revenue, and everything else I think we can get by with freehand here. All right, so we know that this is going to be our marginal revenue curve. This is going to be our demand and our price. Whoops. Demand and our price. Here is our quantity axis. This is our price axis. And since we're making a profit, again, I'm going to go here. I'm going to pick a point in the middle of the chopsticks and down kind of low. And I'm going to make my ATC, which looks a lot like an upward quadratic here. So there is my ATC. And then I'm also going to bring in my marginal cost curve through here. My Nike swoosh marginal cost curve. And that's nice and clean. Okay, so profit maximizing quantity at Q sub G. So MR equals MC is this spot here. And because that vertical line there is so important, I'm going to go ahead and use my straight edge here. And actually going to make that real nice there. Okay, so keep in mind someone else is going to be grading these, so you guys taking the time for this neatness can really help for your overall score. So this is Q, quantity sub G they're using. And the profit maximizing price, well, we know we have to elevate to the price axis. And so I'm going to come over freehand here, and I'm going to call this price sub G. All right, we've got A, 1, and 2 done. Part 3, average total cost curve labeled. We did that. The area representing the consumer surplus shaded completely. Okay, so just a quick review. Sometimes when you do this on a market type, it can be a little confusing. But normally, in traditional, a nice simple supply and demand curve, you know that your consumer surplus is up here and your producer surplus is here. So they're saying, what's the area representing the consumer surplus? Well, the consumer surplus, again, is going to be the difference, is going to be the price axis, which is the demand price axis, and equilibrium here. It's that upper triangle. So you can see there's the price. This upper triangle here is representing that one right there. So shaded completely, I'm just going to cross-hatch that right here. Okay. And they want that shaded completely. We have that there as part 4. So this was actually part A, or question A, and it had 4 pieces to it that was all based upon the graph. And I think we've got it there, okay? Let's move on to part B. Suppose demand for prescription drugs increases and Gigantic hires its warehouse workers in a perfectly competitive labor market. Now, this is a very recent trend test-wise, and what's funny is if you're an AP Calc student, the trend in both AP Economics and AP Calculus is they're moving toward merging concepts within one question. So what's kind of unusual here is that we had a market type question, we had a POG question, product output goods market question, and it was a monopoly. And within the same question, now they have a RIF, or a resource input factor market question. So that really keeps you on your toes. So I'm going to go up to here for question B. Just want to do a quick review. Don't forget there's the 2 types of markets. We have the monopsony and perfect competition, and this is where Mr. Carlson and Mr. Paulson make an appearance in class. So we have Mr. Carlson and Mr. Paulson. Okay, and this would be perfect competition versus a monopsony. So I'm just going to put PC versus a monopsony, which is a monopoly in the labor market, and that was when we had the separation here, and Mr. Paulson stayed the same. And this would be your wage. We go here, and this would be what we would pay. So just a quick review. And if you ever have perfect competition, just like in the POG, you're going to have the market and you're going to have the firm. So off to the side here, I would have the market that would spit out, instead of Mr. Darp in the POG, we're spitting out Mr. Carlson because it would be in the RIF. Okay, just a very, very quick review. And now I want to jump back to this question. All right, now the question says, or it states here again, that the demand for prescription drugs increases. Okay, so Gigantic needs to hire some more people in a perfectly competitive labor market. So it says, what will happen to Gigantic's demand for warehouse workers? What will happen to the wage rate? Now, what I'm noticing right away here for part B is there is no requirement to draw a graph. Now, since there isn't a requirement to draw it, a sketch is extremely helpful to just have you think through it. So if they don't ask for a sketch and you make one, you're certainly not penalized for that. So since this sketch isn't going to be, isn't asked to be drawn, just a quicker freehand one that might not be so neat and straight is going to be fine. But I think this will really help you understand the question on this one. So what we have is we have our demand and supply curve, and it's really important. It's very subtle the way they ask this, but this is the labor market. So this is wage and this is quantity. Okay, and out of the labor market in perfect competition, we have the firm that is next to the labor market, and the firm here is Gigantic Pharmaceutical Corporation, and that's where the number for Mr. Carlson came from. Was actually out of here. So again, this is the resource market, but it behaves very similar to Mr. Darp, coming out of the perfectly competitive market in a goods market, but we're in the RIF here. So this is the firm, and this is actually, I'm just going to put GIG for Gigantic, and here is Mr. Paulson. Okay, now I do want to stress here, it all depends on the test. The reason I like to call it the RIF is we have the resource market, the input market, the factor market. And sometimes instead of Mr. Carlson, they will call it MFC instead of MRC because they'll replace resource with factor. So remember, this is the marginal resource cost or the marginal factor cost. Either one is acceptable. And this is the marginal revenue of the product. So this is the situation we're dealing with. And now I want to go back and read the question. It says, what will happen? So by the way, there's a increase in demand for pharmaceuticals, and you got to be careful. It says Gigantic hires its warehouse workers in a perfectly competitive labor market. Okay, what will happen to Gigantic's demand? Now there's where you got to be careful. It's asking about Gigantic's demand for workers. It's not talking about the market for workers. It's just the store Gigantic. What will happen for the demand for workers? Well, it's going to increase, because they need to hire more people. So what happens to our demand curve, which is just Mr. Paulson? It's going to increase. So, actually, just to to make my picture a little nicer, I'm going to draw my original Mr. Poulsen here a little to the left so I have enough room to sketch this better. Okay, so there was Mr. Poulsen originally. Okay, and there's an increase in demand because we're going to hire people. Okay, so here is the new Mr. Poulsen. So there is Mr. Poulsen, we'll call it prime. Okay, so here's where we were. Here's how many people we hired before. Remember, MRP, where Mr. Poulsen equals Mr. Carlson, that's how many people you hire. Well, now because there was an increase, we're now going to be over here. We're going to be hiring more people. Remember, this is the quantity of labor here, and this is their wage. Okay, so this company's doing well. We got to hire more people. We had an increase in demand for workers, and so we hired more. Okay, not surprising. So we're here now. So it says, what will happen to Gigantic's demand for warehouse workers? Explain. Well, I guess this is one right here. The demand for workers will increase. The demand for workers will increase. Or I'm going to say and the MRP, which is fine to write it that way, MRP will shift right. Okay, which is what happened here, okay? So that's our explanation. This one's a little bit weird to explain. They actually just told us the demand for prescription drug increases. Gigantic hires more workers. They're kind of giving it away in the actual statement. So some students were a little confused, like, well, I'm supposed to explain what they just told me? It says they hire people. So what happens to the demand for warehouse workers? It increases, shifts right. Okay? Not the best question. Part 2, though, is a really good question. It says, what will happen to the wage rate Gigantic pays its warehouse workers and the number of warehouse workers it hires? So what's going to happen to the wage rate? Well, that's a question about Mr. Carlson, everybody. Now remember, Mr. Carlson came out of equilibrium from the market. And so what happened to Mr. Carlson? Hey, we're talking about Mr. Carlson. Nothing. He's the same guy over here. Just because Mr. Poulsen shifted right, Mr. Carlson's still Mr. Carlson. There's no change in the wage. And the reason there's no change in the wage is because we're talking just about what's happening at Gigantic. An easy mistake to make, and what some students did on this one, was instead of shifting Mr. Poulsen, they went into the marketplace and shifted the whole demand curve, which would have raised Mr. Carlson. But that's not what the question says. The question says Gigantic Pharmaceuticals has an increase in, needs to hire more workers. That was the main issue to differentiate with this question. So what happens to the wage rate Gigantic paid? Gigantic pays? No change in the wage rate. The wage rate does not change. And the reason is MRC, and I'm just going to put MRC, which is equal to MFC, whichever one you want to use is fine. MRC, which is equal to MFC, is perfectly elastic. Or you guys could say, if you prefer, you could say, excuse me, it's a constant. It's fine. But it's because we're in perfect competition. Okay, and then what happens to the number of warehouse workers? And the number of workers increases. The number of workers increases. Okay, so just to contrast this one, so that's it for that question, but I do want to just show you, here was the most common. I'm going to put MCWA. Here was the most common wrong answer, but it's a good wrong answer. This was the misunderstanding some students made. They thought, well, there is an increase in demand for workers in the marketplace. So they thought, oh, there's an increase in demand. And so what happened was they said, well, here was Mr. Carlson. Well, this increase in demand increased Mr. Carlson up here. And here was Mr. Carlson prime. And so what they wound up thinking that the wage increased. And the misunderstanding here was, where was there an increase in demand for workers? It was not in the market. It was just a Gigantic Pharmaceutical. Okay, easy mistake to make on that one. All right, so that was part B. All right, let's look at C. C says, After Gigantic's patent expires, another firm enters the prescription drug market and produces an identical drug that sells for a lower price. This happens all the time when patents run out. And what will happen to Gigantic's producer surplus? Instead of we could look at this graph and think about it, but maybe it's a little bit easier just to make this sketch. And I want you to just pretend if we were looking at it this way. Okay? What's going to happen if all of a sudden there's now competition? If this is what was going on and you were a monopoly, and this is what you're going on, all of a sudden you have more people involved. What's happening to your producer surplus? Your producer surplus is going to go down because there's an increase in supply of people supplying this product. And so all of a sudden you had a monopoly on the market, and all of that producer surplus now has to get shared with another company. So what's going to happen when you have competition? Well, your producer surplus goes down because you have competition. So that's the easy answer to that one. It was just producer surplus decreases. Now you don't have to explain it, but you could if you needed to. So it just decreases, so that was 1. And then for part 2, it says, what will happen to consumer surplus in the prescription drug market, and explain. I'm going to actually draw that sketch again. So if we have this going on, supply and demand, and here was our consumer surplus and producer surplus. And it's a little bit tougher to just see on this graph, and I don't want to have to erase or tweak this graph, so this will serve the purposes. What happens to consumer surplus in the prescription drug market? Well, if all of a sudden there's an increase in suppliers, let's just go ahead and do that. All right, there's an increase in suppliers. All right, so there's my new supply curve. Well, now let's look what happens. I'm actually going to erase that producer surplus, and I'm going to now make, here's my new equilibrium. Look at the expanded consumer surplus that we just got. And in fact, you can see now, based on the last question, you can see where the producer surplus is now. It's getting smaller. Okay? There's an elasticity issue I don't want to get into. Not really asking about the producer surplus in this one, but it's very easy to see. You had expanded consumer surplus. And you don't actually need the graph to justify this, but it says what happens when there's more competition. Well, whenever there's competition, it always results in 2 things. Competition always leads to lower prices and better quality. And that's kind of a foundational principle of capitalism. Okay, so you could say right here, competition leads to lower prices and higher quality. Now it says in this one the drug is identical, so it's not going to be any more powerful, but just making this statement that you understand that more competition leads to lower prices and higher quality, even though in this situation the quality is the same, it's fine. But that's your explanation. So you could also say right here, if you prefer, get this graph out of the way, you could say, if you wanted to keep it real econ based here, you could say an increase in supply increases consumer surplus. Okay, and if you felt like it, since I'm drawing this the 3rd time here, you could have this sketch as a part of your explanation if you felt like it. And so you have a little bit of flexibility there. There's S prime, and you could show this if you wanted as part of your explanation. Your call there. Okay, so there is question number 1, addressing a POG, a goods market or product market with the monopoly making a profit. And then we jumped over to the resource market, didn't have to graph it, but had to understand it. And then just a little thing about consumer and producer surplus. All right, so there is question number 1. Let's move on to question 2. Okay, question number 2. on 2019 Set 2 says, hats are produced in a perfectly competitive industry, and the government imposes a per-unit sales tax on hats. Using labeling from the graph, identify each of the following. So if you glance at this one, this is a topic that comes up quite a bit. I'm going to do a quick little sketch here. When you were a beginner doing some things with supply and demand, and we talked about government intervention, we would have our supply curve and our demand curve here, and the common one we would do would be cigarettes. Cigarettes is something bad. The government doesn't want people smoking it. So they take advantage of the law of demand, which says the higher the price, the lower the quantity consumed. So they just put a tax on it. And if you remember, we had the S plus tax here. And then you would come to here and you had to remember how to draw your deadweight loss. So you came down right away here. Okay, and you draw your deadweight loss triangle. Then the top of the triangle, you went to the left. And the bottom of the triangle, you went left. Okay, and then we would erase, we would get this little guy out of the way. And we talked about how if we, this wound up being tax revenue, the consumer surplus gets smaller, the producer surplus gets smaller, and from original equilibrium, it divides up this tax revenue into the tax paid by the consumer, and then the tax paid by the producer, but this was all the tax revenue. And this was a typical graph, played around with that a lot. Oftentimes with cigarettes or an addictive substance, the demand curve was a little steeper because it was more inelastic, and that would actually make what was called a tax incidence different. These both look unit elastic, so my incidence looks like it's 50-50. But if my demand curve was steeper, your tax incidence looks different. So for example, if I do the exact same graph here, but make a more steep demand curve, and then I put a tax on here, I'm going to do the exact same thing, but I want you to notice how the triangle's a little different, and also the rectangle. So if I bring this down for my deadweight loss, you can see I now have a scalene triangle, not a nice little isosceles. And then if I go left right here, and then I go left right here, and I get rid of this, if I divide this based on original equilibrium, you can see now the tax revenue is not divided equally. In fact, here's consumer surplus, producer surplus. The consumer pays more of the tax than the producer does. And so that's because whoever's more inelastic always pays a greater proportion of the tax. And so that was just one little thing to keep in mind. Now the picture they give you here, they both look like they have the same slope, which is not elasticity, but it can infer the same results. And we have this kind of a graph to deal with. Now, whenever they do this in a testing situation, they have all sorts of points of intersection. They're doing everything they can to try to confuse you, and you want to stay back remembering this and thinking through this. So we'll use this as a reference as we go through here and see if we can figure this out. So this is hats, and so for some reason hats are being taxed, and probably not because they're a bad thing. They're just taxing it like any other retail clothing item. So it says the hats are produced in a perfectly competitive industry. Now the fact that they say that, you might be thinking, perfectly competitive industry. Well, perfectly competitive, shouldn't we be looking at something like this with Mr. Darp and, what's going on here? Well, they're over here, they're working on the market side here. Okay, this isn't a firm. Okay? So that's why. So don't get confused by that. We're looking at the market. All right, so let's go ahead and analyze this. And so what I'm going to do on this picture here is I'm going to draw this a little bit bigger, and it just kind of eliminates some of the things on here to make it a little easier to read. So, you want to take these out of the way. And I want to draw this. And if it's more of the traditional type of question that I was just drawing there, and it was this situation, and here's my S, and here's my S plus tax, and here is my demand curve, well, then it looks like this point right here, that's W, you can see, and then where it intersects again, this here would be S, okay? And then it looks like this is our deadweight loss triangle right here. All right, there's our deadweight loss. So it looks like this point right here, that is Z. And if I get this out of the way, and we make our tax revenue boxes right there, And I'll go ahead and extend those. And so here's our consumer surplus, our producer surplus, our tax revenue. Let's see, we have point R, which doesn't look like we need it here. X, we don't. Y, we don't. V, I think we have everything we need. There's a T value right here. Okay, and so let's just focus on this graph, and then also on the quantities here. It looks like original equilibrium, because sometimes these can get a little overwhelming. Original equilibrium here at W, it looks like that was occurring at quantity 3. And then the tax, when we moved this over, this one was quantity 2. Okay, and then original price, original equilibrium price right here, if we follow it all the way around, that was P2. And then after the tax was made, so the top of the box here is P3. Okay, and if we need something else, we'll see, but this might be a little bit easier for you to follow. So let's go back to the question. It says, using the labeling from the graph, identify each of the following: the after-tax price paid for by consumers and the after-tax quantity. Well, what I'm actually going to do is just right before this, if you wanted to know the price and quantity, you just go to equilibrium. That would be easy. And if you have a tax, then it's going to be the new equilibrium. So it's just this thing right here, and this will tell us both things. So it says the after-tax price paid by consumers and the after-tax quantity. So here's our new equilibrium. So that would be S. So it looks like that would be S is occurring at P3Q2. So I'm going to put my answers up here. Actually, maybe we'll do this down here. Start with A. And so the answer to A1 was the after-tax price was P3. And we said that was occurring at quantity 2. Okay, that's how you'd write your answer. Part 2 on this one says the area representing the total tax revenue received by the government. So here was our tax revenue box right here. And whenever you need to represent these in a test situation, you just write the coordinates of the corners of the shape. And so since it's a rectangle, the order doesn't matter. The order matters, but just the one you start with doesn't. So if we look right here, if we start at the corner P3 here, so we're going from P3 down to P1, over to Z, up to S. So this right here, this little spot we wound up needing, that's P3. Or sorry, that's a P1. Okay, so it goes P3 down to P1, over to Z, up to S. And so that's what you can write. So I'll say P3 to P1, which goes over to Z, and then goes up to S. And that's the area, that's the rectangle representing the tax. Okay. See, since I have room here, I'm just going to put B right there. All right, it says, now assume instead that the demand for the hats is perfectly inelastic at Q3, while the supply and per unit tax remain unchanged. Okay. Well, what I'm going to do is draw a few graphs here, because this can be a little confusing if you haven't done it for a while. So I think I will I'll put these across here. Here's what they're saying is going on. They say, okay, now it says, assume the demand is perfectly inelastic. Well, if the demand is perfectly inelastic, there's your demand curve right there. But they're saying that the supply curve is still here, and then the S plus tax here is still here. So they're saying this is the curve you have to analyze. Okay? Now, in my opinion, if you're trying to analyze this one, I like to put with it what's called a helper graph. And the helper graph, instead of perfectly inelastic, it's just relatively inelastic, and it kind of helps you. So I'm going to do a transition graph from this one. What I want to do is I want you guys to imagine my demand curve is now just getting steep. It's not going to go vertical, it's just going to be relatively inelastic. And let's see what happens to all of our shapes here. So I'm not going to make it, again, perfectly inelastic. I'm going to go pretty inelastic, okay? So there's that, and there is our S and S plus tax. Okay, so let's just analyze and see what happens when we do that. If we did that, here would be our deadweight loss, okay? And here would be the top and bottom of our tax revenue. Okay, and I'll get rid of this. All right. And you can see the consumer surplus is really getting big. And you can see that the producer surplus really didn't change. And if you guys think about it, well, look what happens with the producer surplus. The producer surplus has an edge with the supply curve, not the demand curve. So producer surplus hasn't changed, but consumer surplus is certainly getting bigger. Okay, and what's also happening is the tax incidence, talked about that before, is changing. Now the consumer is paying more of the tax than the producer. But I want you guys to imagine here, here's what's going on, okay? So we started, now this is relatively inelastic, and so now what I want you to do is let's go to this one and see what's going on. Now, since I'm perfectly inelastic, there's actually no deadweight loss. But here's what happens. We still, at the bottom, and I'm hoping you can see this from here to here. I want you guys to notice very closely here. Look at these two values right here that were the top and the bottom of the deadweight loss and the top and the bottom of the revenue box. Okay? Now, just because I go vertical and don't have the triangle, I still have the spots. So you could see I had this big isosceles triangle. Now it's an scalene triangle. And even though the area is changing, this did not. These two distances from there to there, and now up here, here to here, that doesn't change. That's still the top of your box and the bottom of your revenue box. Now there's no deadweight loss, and again I'm going to get rid of this, but I have to redraw. Okay, I'm going to get rid of the side there. But this is still my tax revenue. Okay, so that's still my tax revenue box. And I want you to look what's happening to producer surplus. Still just sitting there, didn't change the whole time. But now consumer surplus, the argument is it becomes infinite. It's not capped anymore. And we still have our tax revenue box. So I'm just going to put TR right here, TR for tax revenue, and here's my tax revenue. Okay. All right. Now, some of you you don't need a graph and you can answer this, but I'm just showing you graphically what's going on. Okay. So here's what it says. Now assume instead the demand for hats is perfectly inelastic at Q3. So this all happened here on our picture at Q3. So I'm actually going to put this Q3 right there. Okay. So at quantity 3, that's happening. Will the after-tax price paid by consumers be higher, lower, or the same compared to your answer in part 1? So let's go ahead and use this. I'm going to put my marker right here. Okay. And what I'm going to do is, what happens if all of a sudden now I'm here? Okay. What I want you guys to see is, I'm going to sketch on here. If this demand curve goes vertical and the hinge is right here at W, okay, because it says at Q3, there's my price. I want you to see now where the line at Q3, this would be my new demand curve. Okay, that would be my inelastic demand right there. That's this line. That is now intersecting right there at point X. Okay, so the question says, will the after-tax price paid by the consumer be higher, lower, or the same compared to your answer in part A? You guys remember our answer was it was price 3. Well, now you can see it elevated and now it's at price 4. Okay, so all of that work here just to answer number 1 here for B, it's going to be higher. Okay, then for part 2 it says, will the total tax revenue received by the government be higher, lower, or the same compared to your tax revenue in the first part here? So this was probably easier, and the picture starts getting changed here. So I'm going to switch to red here, and I'm going to highlight the original tax revenue on here. So our original tax revenue box is this red rectangle right here. Okay, so there it is. That's the original tax revenue. But now, if you guys now look at here, what happens? It's now this rectangle. I'm going to shade in that rectangle on here now. Okay, and that rectangle I'm going to do in green. Those points of intersection now, with this thing vertical, would now be intersecting here, and now all the way over to here and to here. So it's going to be this one, and I'm going to cross hash this way. So obviously some of it's going to be overlapping. Okay, and so here's what your hopefully seeing. You can see that as far as the distance between P3 and P1, the height of my rectangle is the same. The heights are the same, it's just a little bit higher on the graph, but the distance from P3 to P1 is the same as the distance from P2 to P4. So the height of my rectangles are the same, but clearly you can see the length. I'm going all the way from 0 to Q3, whereas before I was going 0 to Q2. Okay, so that's it's this box, but right there it is. It would be green right there. So that one's representing this one right here. Okay, so that's what I'm saying. All right, so my conclusion there is going to be, is the after-tax revenue higher, lower, or the same? My answer is going to be higher or greater, and explain. So we will say higher or greater, and the main reason is because Q3 is greater than Q2. Quantity 3 is greater than Q2, and I'll sneak this in, which is the length of the tax revenue rectangle. Okay, and that will illustrate you know what you're doing. Okay, now it's time for part C. If the demand for hats remains perfectly inelastic at Q3, okay, so now we kind of have our these two pictures here. All right, if the demand for hats remains perfectly elastic at Q3 and the per unit sales tax is reduced, will producer surplus increase, decrease, or stay the same? Okay, so let's say the sales tax is lower. So what I want you guys to do is let's start with this picture. So I'm going to draw a new tax curve, and just so it will highlight here, we use this one. I want you to pretend the government comes in and says, hey, the tax is going to be lower. And so lower would be like right here. Okay. Now, this is where our deadweight loss triangle would be, but I want you guys to see what's happening. We would erase that part and we would make a new deadweight loss triangle and all that. And then on this one, you can see if we did that, say we reduced it to here. Let's draw it all the way through. Okay. And now we'll go to this one, and now we're going to lower the tax all the way through. Okay. Now, I want you guys to focus in on this one first. If the tax lowered, we'd be drawing a brand new picture. There would be our deadweight loss. Everything would be different. In fact, we'd have a really narrow tax revenue, more producer surplus, more consumer surplus. Even here, same thing. We'd have this really small deadweight loss triangle. More producer surplus, more consumer surplus, less tax revenue. But look what happens on this one. If you come through with a lower tax, there's no impact on, we don't have a triangle to draw. And so I'm going to draw this a little bigger just in case you're not seeing that. Oops. And so here's what we have. Here is our perfectly inelastic demand. Here is our S plus tax, and here's our S. Okay, and here is our tax revenue. Okay, and I'm going to erase that. And so this is our tax revenue. Up here is my infinite consumer surplus, and here's my producer surplus. So what they're saying is only in this case. It says if the demand remains perfectly inelastic, what would happen if the government lowered the tax? So now I'm going to do that here in red. So the government says this tax is too high, we're going to lower it. So now they decide to do this. They say, okay, well, we're going to lower the tax to here. Okay, let's see how our picture gets affected. We would say, oh, well, I'm going to get rid of that. We would say, oh, well, here's the top of your tax box right here. All right, consumer surplus got expanded. And we're going to get rid of this part of the tax curve because it makes the picture hard to read. So let me redraw here the producer surplus. Okay, and so what wound up happening is the tax revenue certainly went down. The tax revenue came down, but the producer surplus stayed the same the entire time. So this thing moving up and down, what it changes is the tax revenue box, but the producer surplus is already made by, this line is making that edge, and this is going to be the bottom of the tax box wherever you put the top of it. It doesn't matter. This is fixed. So they're wanting you to see that that will not change. So for part C, I'll just put that in there. Is the demand increase, decrease, stay the same? We will say stays the same. Okay, stays the same. And the reason is that inelastic demand, say perfectly inelastic demand, I'm going to say both. You don't have to say one, but I'm going to say changes consumer surplus but not producer. And if you wanted, you could actually draw the graph. That could be part of your explanation too. Okay, and again, when it comes to getting your points, make sure you get your points for stays the same. And if you're struggling with articulating why on a multiple point question like this, you at least get your points for the right answer, and maybe you lose a point in your explanation. So sometimes you might see these and know the right answer, and maybe miss a few explanation points, but get the points you can. And remember, you don't have to get everything. And so there is question number 2. Let's move on to number 3. All right, question number 3. Right away, you look at this and you say, payoff matrix, dominant strategies, got to figure this out. But it does look a little bit unusual in this through some students in 2019. This says, first we'll read the question, then we'll dive into analyzing the strategies. It says, Jackpot Florist and Boulevard Gardens share the market for floral bouquets in Tulip Town. Jackpot's deciding whether to close at 6 or close at 9. Boulevard's deciding whether to offer delivery or no delivery. The payoff matrix shows the annual profits for each combination of actions that the firms can choose. The first entry shows Jackpot's profits. The second entry shows Boulevard's profits. Okay, so the thing that threw some students on this one was that these weren't the same things. They thought, well, this should be delivery and no delivery, and this should be 6 and 9 o'clock. They actually had different actions, but that was okay because they were still working together, and that was a little thing that threw them. So don't let that, if the payoff matrix is going to work the same way, even if the decisions aren't identical here, the options aren't. But the first thing I want to do, just to make sure we're reading this correctly, remember, Jackpot's decisions, whatever has to do with Jackpot, is going to be the values on the left side. So I'm just going to highlight those, makes it a little easier to go over. All right, and then in red, I'm going to just underline Boulevards. And just it'll allow us to make it much easier, make it easier to read, and they'll just kind of jump out at you as we figure this out. So before we read all the questions, just do your dominant strategy analysis and figure all of that out. And when you do that, you'll probably have answered almost all the questions anyway. So the first thing to do is let's figure out if there's any dominant strategies going on. So if you want to know if one of these has a dominant strategy, you force the other one to make a decision. So let's figure out if Boulevard has a dominant strategy. So we'll force Jackpot to make a decision. Okay, so let's force Jackpot. I'll just put Jackpot. Let's force Jackpot to close at 9 p.m. Okay, so I'm going to force those guys to do that. Okay, so if Jackpot closes at 9 p.m., all right, let's see what Boulevard will do. So Jackpot closes at 9. What's better for Boulevard, 50 or 40? 50. Therefore, Boulevard will deliver. That would be their decision. Okay. So next, let's say, all right, so then what happens if Jackpot closes at 6 p.m.? What if they do that? Let's force them to make a decision. Let's see what Boulevard will do. So now let's go up here. If Jackpot closes at 6 instead, what's better for Boulevard, $30 or $20? $30. So it looks like Boulevard will deliver. Well, there you have it right there. Boulevard has a dominant strategy. Regardless of what Jackpot does, Boulevard's going to deliver. Okay, so my conclusion right here is Boulevard, I'll just say Boulevard has a dominant strategy, and their dominant strategy is to deliver. Okay, so they're going to do that no matter what. Okay, well now let's see if Jackpot has a dominant strategy. We're going to force Boulevard to do something. So I'll scoot over a little bit here. All right, so let's, I'll just put B-O-U-L. So let's force Boulevard to deliver. Okay, let's force Boulevard to deliver. Let's see what's best for Jackpot. So Boulevard delivers. So we're looking at this column. What's better for Jackpot, 35 or 25? 35 is better, closing at 6. So they are going to close at 6. I'll just put that. Actually, just, so we have this here, I'll put JP 6. Okay, that's better for them. All right, so now let's let Boulevard not deliver, so ND. If Boulevard does not deliver, now we're at this column. What's better for Jackpot? 55 or 45? 55 is better. 6 o'clock is there. So this is weird. They both have a dominant strategy. So regardless of what Boulevard does, JP, Jackpot has a dominant strategy, and it is to close at 6 p.m. They'll make more money. Okay. So what that should maybe make you lean toward is, well, maybe they didn't make a lot of money to cover their costs, so closing early, maybe they're kind of slow in these last 3 hours, so it's not worth it, so they make more money closing earlier. Okay, but regardless, they both have a dominant strategy there. So here's what we're going to do. If they have a dominant strategy, then let's go ahead and circle what they're going to be. No matter what, Boulevard is going to deliver. So we could say, well, that's going to be this column. This is what's going to happen. Boulevard will deliver, and JP is going to close at 6. So we have just discovered what's going to happen. Our Nash equilibrium is right here. We've got it. They will close at 6. Jackpot will close at 6, and Boulevard's going to deliver. And here is the Nash equilibrium for this scenario. We've got it. Okay? Now we'll see how many questions we've answered just going through this. All right? And then we'll continue. So it says, assume both firms know the information in the matrix and act simultaneously and independently. Is Jackpot's dominant strategy to close at 6 or at 9, or does it not have a dominant strategy? Well, we just figured that out, didn't we? So Jackpot's dominant strategy was to close at 6. Okay? So Jackpot, dominant strategy, close at 6 p.m. Got it. B. Suppose Jackpot chooses to close at 6 and Boulevard chooses no delivery. Okay? So that's not Nash equilibrium. That would be here, by the way. So it says, suppose Jackpot chooses at 6, Boulevard chooses no delivery. So I'm pointing right here to the square we'd be in, the combination. It says, is this the profit maximizing action by Boulevard? Explain using values from the payoff matrix. And we can just say no, because 30 is greater than 20. Boulevard should deliver. So to answer the first question, is this the profit maximizing action for Boulevard? The answer is no. And we're going to say Boulevard should deliver. And our explanation, it says use numbers from here, and we're going to say $30 is greater than $20. Okay? And that's, you don't have to go real detailed and say, explain everything. If you state this, you're demonstrating from being able to read this that why you put that there. So that's fine. Okay, so there's your explanation and your answer, no, and there. Part C, how much profit will Boulevard earn in Nash equilibrium? $30. Kind of overlaps with that last question there. Part D, suppose, we're right here. Suppose these two firms merge to form one company with 2 locations and still face the same actions and payoffs. Which strategies would the new company choose to maximize combined profits? Well, all you have to do here for that one is just add the 2 and see which one's the best. And we'll see if we would still do the same thing. So what I'm going to do is insert here in the question. I'm just going to add those so we can look at them, and they'll be sitting here. Okay, so on our first one here, that's Nash equilibrium, I'll just put it up here. That would be a total of 65, okay, if they merged. If they merge here, we have 75. Down here, also 75. And down here we have 85. So it looks like if they actually combined forces, they would make the most money not delivering but staying open until 9. So let's see what this says again. Suppose the two firms merged to form one company in 2 locations and still face the same actions and payoffs. Which strategies would the new company choose to maximize combined profit? We would say close at 9 and no delivery. Okay, and that's just demonstrating we know how to read this. All right, now part E. Now assume that instead of merging, Jackpot proposes a plan to cooperate with Boulevard. Jackpot would agree to close at 9, all right, and Boulevard would agree to no delivery. Interesting. So you can see this would make them a good little chunk of money. Not as good, not the highest one, but better than what they were doing, because what they're going to do is make 35 and 30, but they say, hey, let's make a deal. Let's agree to all close at 9, and you don't deliver, and look, we'll actually be doing better. So this is his proposal. Okay, so Jackpot says, let's do that. I'll close at 9. There's no delivery. If you break the agreement, you must subtract $12 from your profit and add it to the other firm's profit. Now, assuming the agreement was in effect and enforced, redraw the matrix, including the player's actions from the playoff. All right, so what I'm going to do is redraw this down here. And I'm not going to put everything on here. I'm just going to draw the rectangle. We'll divide this and see if we can figure this out. Okay. So here's the agreement, right? So this is what's going to happen. We're going to go 45 and 40. Okay, so here was the deal. Okay, so it says, I'm going to restate what he said. He said, if anybody breaks the deal, you subtract $12 from what you were going to make, and you have to add it to the other person. Okay, so since they agreed to no delivery, that's the deal, and this is the delivery. And this is the 6, and this is the 9. Okay? So I'm going to write these numbers in, but I'm going to erase them. Okay? Make sure you realize that. I'm going to erase these, more than likely, as we explain here, 55, 20, 25, and 50. Okay? And so since this is the new one, I'll leave brown or black here as the original, and I'm going to, even though these haven't changed, this is part of the agreement. Okay, so this is what we're going to do, and if you break the agreement, we ding you 12 and we add it to the other guy. Okay, so Boulevard has agreed to not deliver. So see if this makes sense. If Boulevard agrees to not deliver, the only way we would end up in this square is if Jackpot broke the deal. So according to the rule, if Jackpot breaks the deal, we have to take 12 away from him, and we have to add it to the other guy. And I'll put those totals here in a second. Now, if we open at 9 but we deliver, that means Boulevard broke the deal. And we have to take his $12 and we give it to Jackpot. Okay? Make sure that was readable here. Minus 12. Okay. Now, if they deliver and close at 6, they both broke the deal, and so they both broke the deal, so they both lose $12. Okay, but they get the other guy's $12. Hopefully that makes sense. Okay, and so then we have to redraw the matrix. So, just accounting for all of these, I'm going to put these in. I'll put these in green here. So here's my new matrix. This drops down to 47, or sorry, 43, and this one increases to 32. All right, and then over here, these stay the same because they both lose and gain $12. So this is 35 and 30. Over here, 37 increase, and then we lose 12 here, so this goes down to 38. And this was the original agreement, so I'm just going to underline them. They stay the same. Okay, so here is our new payoff matrix. Our new payoff matrix has these values. Okay, and I'll circle that as well. All right, kind of interesting with the penalty involved. So it says, assuming the agreement was in effect and enforced, redraw the matrix. There it is. So back over to here, this is actually E. And I'm just going to write C, the matrix, because I just drew it right here, okay? So there it is. And again, it's in green. Green are the ones. Assume Boulevard is a profit-maximizing firm and there's no antitrust concerns. Would Boulevard agree to Jackpot's proposal? Explain using specific values from the redrawn matrix. Okay, so let's see. If this is their agreement here, how is this going compared to what was going to happen up here? Now, in the original situation, now we're talking about Boulevard is the question. In the original situation, Nash Equilibrium, Boulevard was making $40. In this new arrangement, if they agree to it, they're going to make 40. Boulevard makes 40. So this is definitely a better deal for 40 for Boulevard, because 40 is better than 30. So it says explain using specific values. So would Boulevard agree? And so that was 1, this is 2. And so I would have said yes. Yes, Boulevard should agree. Because, and of all the numbers here, this clearly communicates you know what you're doing. Because $40 is greater than $30. And this cuts through all of the clutter. If you guys just see this, this communicates clearly you knew what you were doing. And so that's all I have to see is that inequality right there. Okay? So that is question number 3, a payoff matrix with a little bit of detail here. So going through that and explaining, hope that made sense. You have, obviously, as far as time goes, you want to pick up the pace and get through that as quickly as possible. But there it is, a payoff matrix. That was question 3, and that concludes AP Micro 2019 version 2 or set 2 of the exam. All right. Thanks for watching. We'll see you guys next time.